So I'm going to go with box plot, and when I clicked on box plot, it's going to bring me to a data set where we're going to be able to work with this data set to be able to make a box plot. By the time all is said and done, you will have made this box plot right here, and I'm going to move this over so that way we can get started on that. So this box plot is actually really easy to make. Okay, I've got this individual. He decided, hey, you know what? I want to offer free delivery, and I'm going to guarantee that when I do this free delivery, that that our pizza is going to be 140 degrees, a minimum of 140 degrees, and I'm going to offer free delivery. And I want to see, what can I do? How far can I travel? How many pizzas can I deliver in a particular run, and still be able to make this? Okay, so this particular pizza chain, he timed his delivery drivers with their first, second, and third pizza. He was setting them up with 3 pizzas, and then he also told them, hey, take the temperature of the pizzas when you get to the third place, so that way we know how hot that pizza is. And so what we have to do in order to make a box and whisker plot is literally just highlight those headings and scroll all the way down. And right now we're not going to do the third pizza temp because the third pizza temp is on a completely different metric. If I were to do this, actually I'll go ahead and do it just to show you how bad it is. Okay, so I'm going to highlight this and I'm going to do insert. And then I am going to go to where there's a histogram and I'm going to say, give me a box and whisker. And you notice those temperature things, they're all the way, the temperature, all the way up there. I don't want that. So I'm going to get rid of that. So I just got rid of the temperature, and we're going to only use that data right there. So I've modified the data, and then I'm going to change the chart type, or I'm going to change the chart title. And this right here is non-rush hour delivery times. Okay, so when we look at the non-rush hour delivery times, and I'm going to delete this, you'll notice... look at something. Yep. With the non-rush hour delivery times, you'll notice that you have the first pizza right here, the second pizza, and the third pizza. But wouldn't it be good to have just a little bit more information in here? It's kind of not hard to know, hey, what is it that I'm actually looking at? So I'm going to click on this chart, and I'm going to say, okay, design, add chart element, and I want... I want data labels, and I'm going to put those data labels right there. So what we just did here is with these data labels, you're able to see, okay, we've got the limit that is not an outlier, that's going to be 10. So you can literally say min not an outlier is 10. Okay, and then we've got Q1 is going to be 12. Then we've got the median and the mean, this is a little hard. I'm going to zoom in. Let's see here. It's hard to tell which one's which. It looks like the median is going to be... It actually looks like the median is going to be 16.2 and the mean is going to be 16, but that doesn't seem right. Or it might be right. Let's see here. Equals average. All that we've got to do is find one of them, and then we'll know which one's which. So we've got the average. Well, that didn't work. Not sure why. Oh, I know why. So I spelled average wrong. Average. So average is 16.2. And so we know that the average is 16.2, or the mean is 16.2. And then the median is going to be 16. So I've got all that fun information, and then also Q3. Oops. Q3 is going to be 20. And then the max not an outlier is going to be 29. Now you might be wondering, what is an outlier? what is an outlier? And I'm so glad you asked. I'm going to tell you what an outlier is. There's this fun little formula, and the formula is 1.5 multiplied by the interquartile range plus Q3 or subtracted from Q1. Anything beyond that is an outlier. And you're like, oh my goodness, that's a lot of information. No worries, I'll put it right here. Okay, what is an outlier? 1.5 multiplied by IQR plus Q3 equals upper outlier limit. Okay, and then also 1.5 multiplied by IQR. And we're going to put Q1 minus, and just for continuity, we're actually going to put Q3 plus 1.5 multiplied by the IQR, and then Q1 minus 1.5 multiplied by the IQR equals lower outlier limit. So what is the IQR? IQR is the value of Q3 and the value of Q1, and you subtract them or take the difference from each other. So that's going to be 8. The IQR is 8. Okay, it's just the distance or between the first and the third quartile. So it's 8. And so we've got, to find the limit, we do equals 20 plus 1.5 multiplied by 8. So it's going to be 32. So any value greater than 32 is going to be an outlier. Same thing, equals 12 minus 8 multiplied by 1.5. Which is going to be 0. So anything below 0 is an outlier, and anything above 32 is also an outlier. And so you'll notice that's the reason why we don't have any outliers. So for what you're doing, I think I only ask for, that, and then also for the information on the outliers. So if we have information on outliers, let me show you what it is that you should be documenting. When you have an outlier, what you would say is 3 outliers above at 37, 39, and 40. Okay, so we know that we have 3 outliers that are above, and there's no outliers that are below. Next, what I want to do is I want to click on this box and whisker, and I'm going to go to Design, Add Chart Element. I already have a chart title, but what I do want is I want a legend. And I'm going to put the legend to the right, and the reason why is I want to know what it is that I'm looking at. Okay, and so you'll notice it tells you, okay, the blue is the first pizza, orange is the second, gray is the third, and so we've got this fun little box and whisker plot, and we're able to see the different outliers at different levels. Now, one of the things that I love about box and whisker plots is that box and whisker plots are very much so, just a measure of position, or better yet, location inside the data. Okay, and so if we were to take a look at this, okay, and we sort this by the first pizza. So we're going to do this really quick. We're going to sort this data. I highlighted it from first pizza, and I'm just going to right click and I'm going to say sort smallest to largest. So I sorted it smallest to largest. And so I have a total of, let's see here, I've got a total of 90 pizzas that were, or 90 deliveries that were made. Now with these deliveries, I have, each one of them has a position in the data set, or a location in the data set. So this one is in the first position, this is in the second, third, fourth, fifth, sixth, and so we're going to bring it all the way down to the 90th. So there is literally somebody in every single one of these positions. Okay? So when we have this, and we want to use our different formulas. We're going to find a formula which, let's go back to the PowerPoint really quick, and we're going to find the formula to find the location of any percentile or any percentile or any quartile or any position at all. So this right here is that formula. Okay, great formula, but we're going to expand on it a little bit. Okay, this is another example where we have values in students' heights from shortest all the way to largest. When data is lined up, each one of them has a position or a location and a value. Okay, so their location might be one number, but the value associated with that location is going to be a different number, most likely. Okay, so the location is the position where the piece of data is located in the data set. So you've got the location and it's located in a particular position. If it's the lowest value, right here, it's going to be a number, it's going to be in the very first position, but then if it's the highest value, it's going to be in the highest position. Okay, so then you also have the values that correspond to the location. So it may be in the fourth position, right here. It might be right here, but the actual numeric value is the numeric value of the variable that's in that fourth position is actually going to be 63. So you're going to have a position or a location, and then you have the actual value associated with it to the right hand side. Okay. Now where this gets a little tricky, we're going to come right here and we're going to use a little bit more information. Okay. And we're going to bring it to the larger data set in just a second. So we're going to use this formula right here. We're going to do the percentile over 100 multiplied by n plus 1 equals the location of a percentile. Okay, so say for instance, I want to find the Q1. Okay, I would do 25 over 100 multiplied by 10 plus 1, so that's going to be 11. So let's get a calculator. And we're going to do 11 multiplied by 3 times, or 3 divided by 4. Okay, so that's 8.25. So that is the location. That is the location of the third percentile, or the third quartile. So that's really easy. Let's just go and find the location of 8.25. Well, we've got the location of 8, and we've got the location of 9, but we don't have any location of 8.25. So what do we do with that? Well, that's a really good question. So when we have a location of 8.25, we're going to use this fun little formula right here. We're going to use the formula and say we're going to take the value of the 9th and the value of the 8th. Okay, so the value of the 9th, and I'm going to just go enter, make this a little value of the upper is going to be 72 minus 70, so minus the value of the lower, and then we're going to multiply that by the remainder. You remember the location when we came up here, the L sub P equals 8.25. Okay, so 8.25, this 0.25 is the remainder. So the location remainder, which is going to be 0.25, and then we are going to add it to the location of the lower. Okay, so what we have here now is, I'm going to pull up that calculator again. We've got 72 plus 0.25 multiplied by the difference. Sorry, I accidentally did 72 minus 70. So I recant there a little bit. So 0.25 multiplied by by the difference plus 70. So what is the difference between 72 and 70? 72 minus 70 equals 2. And then 0.25. So you have 0.25 multiplied by 2. So that's going to give you 0.5. So 0.25 multiplied by 2 is 0.5 plus 70 equals 70.5. So the value of Q3 is actually 70.5. So we use this fun little formula right here to give us the actual value of Q3. This one right here gave you the location of Q3. This one right here gave you the value of Q3. So make sure that you know the difference between finding the location and finding the value of Q3. Okay, and so we've already gotten into box plots a little bit, and I'm going to come right back over here and come to this box plot. And so I've got this this box plot. We've got a total of 90 observations. So if we do the same thing, we're going to do equals 91, because remember it's n plus 1, so 91 multiplied by, and if I want to find the value of Q1, I'm going to do 91 multiplied by or 91 multiplied by 1 divided by 4. Okay, which is going to be 22.75. So I'm going to come down here and I'm going to do 22.75. Now this is cool because 12 and 12, what that means is there's no difference between the two of them. So if you get something like that, you don't have to worry about it. All that you got to do is put for Q1, just put 12. You notice it's already there. So let's find for Q3. All that we got to do is change it to 3/4, and it's going to be 68.25. Let's go down to 68.25. 68.25, once again, 20 and 20. We don't have to worry about it at all because there's no difference between the two. And then last but not least, we're going to do the median. So the median is literally 1/2, 22.75. So let's go down to, that seemed wrong. 1/2, not 1/4. So 45.5. So 45 and 46, once again, the two of these are the same, so we don't even have to worry about it. It's going to be 16. So like I said, this shows you the location. Okay, it shows you the location of each of these values, and then also when you find the location of each of those values, you're able to find the actual value associated with those locations. And so we've got 25% of the data, 25% of the data, and the actual values of each one of those locations. Now, like I said, this is dealing more with location. This isn't dealing so much with dispersion. Okay. When we have standard deviation deals with dispersion. And so we've got this data right here, and these don't necessarily look that much different, do they? Although you can see that, the first pizza is a little bit more heavy loaded towards the front, but the other ones are a little bit more spread out. But it still shows this is has a better spread, more evenly dispersed on both sides. The orange is a little bit more evenly dispersed, and the first pizza is not quite as evenly dispersed. It's a little bit skewed, and a little bit skewed positively. So let's take a look at this. At least I'm assuming. Yep, it would be. Yep, it's skewed positively. So we have the actual distributions right here. And so I've got the first pizza is distributed like this, and then the second pizza, and then the third pizza. And of these three pizzas, one of them is actually pretty close to normally distributed. And if I were to, I'm going to actually do this. I'm going to do snake. And grab this, see if we can make this work. Capture. Okay. So I just made that into an image is what I did. So don't worry, that's not something that you can do necessarily. But I'm going to make this a little bit bigger. It's going to get a little distorted, but that's okay. And you'll notice, let's see here, 50, and then let's bring that down, 10. Yep, perfect. So we've got the blue matches with the blue, the orange matches with the orange, and the gray matches with the gray. And so you'll see that the way that this is spread out, it does reflect what's up there. However, you can't really see how it's dispersed. You can see, the different quartiles, but you don't know how it's dispersed within each one of those quartiles. You've got to have a little bit more information. And so just be very careful to know this is not showing the dispersion. This is showing you the values for certain positions within your data, showing you the values for certain positions within your data. If you want to know how data is dispersed, you've got to use the standard deviations. And so we've got the standard deviation right here, and we can use the empirical rule like what we covered a little bit earlier in one of our previous lectures, and we can actually show, hey, this is how it is dispersed, whether or not it's evenly dispersed, whether or not it's skewed, and what percentage of data you'll find where with these different values. So once again, empirical rule is for more for different values and dispersion, and then the box and whisker plot is more for positions of data.